In July, China revealed a discovery that sent shockwaves through the electric vehicle world. A lithium deposit in Hunan valued at $1.3 trillion. At first, it seemed like a gold mine for the entire electric vehicle industry, including Tesla. But a closer look revealed the scale of the problem. The volume of lithium found is enough to power up to 30 million vehicles, more than Tesla's entire global production for a decade. The news, which could have been seen as a blessing, quickly became a red flag for Elon Musk's company. With tensions between the United States and China escalating and new tariffs being imposed by Trump, the situation becomes even more complicated. Tesla, despite being a powerhouse of innovation, still relies heavily on Chinese lithium refining. About 70% of all lithium on the planet is refined in China, putting the American company in an extremely vulnerable position. This dependence isn't just financial or logistical, it's a geopolitical issue that could determine who leads the new era of electric mobility. The problem goes beyond supply. With easy access to cheap lithium, Chinese companies like BYD can drastically reduce battery prices, maintaining healthy profit margins while crushing competitors in the global market. If lithium prices truly fall 50% by 2027, as some analysts predict, Tesla will be at a crossroads. Either lower its own prices to compete or maintain quality and watch its market share be eaten away. Neither option is comfortable. Tesla's Shanghai factory, responsible for producing 1.5 million vehicles annually, has become a key player in this geopolitical chess game. It's a pillar of the company's global strategy, but it's located precisely in the country that controls the most critical raw material for its operations. The dilemma is clear. Tesla needs Chinese lithium, but at the same time, it's increasingly exposed to the risks of relying on its biggest strategic rival. Energy independence, once an ideal, has now become a matter of survival. To make matters worse, even the Nevada Gigafactory, one of Tesla's main production bases in the US, still relies on components refined in China. Countries like Australia, Chile, Argentina, and the United States itself produce raw lithium. But this doesn't solve the problem. Without its own refining capacity, Tesla remains hostage to a system it doesn't control. And building a complete supply chain from scratch would cost billions and take years to complete. The current situation has put Elon Musk on high alert. The question he must be asking himself every night is, how to escape this trap? Tesla can continue playing the Chinese game with Chinese rules, or it needs to find a way to break the board. The pressure is immense and time is against them. Dominance of the electric car market will be decided not only by who has the best car, but by who controls the strategic resources that power them. The curious thing is that, while everyone is dazzled by the gold mine discovered in Hunan, no one is talking about what Musk has been preparing behind the scenes. There's a real chance that, instead of fighting for lithium, he's about to make lithium itself irrelevant. The solution wouldn't be to compete in the traditional market, but to eliminate it altogether. This may sound radical, but when the future of your company is at stake, there's no room for timid moves. This is precisely where the biggest twist in this entire story comes in. While the world is betting all its chips on lithium, Tesla is reportedly in the final stages of developing a technology that could redefine the energy base of the entire industry: the aluminum-ion battery with plasma fusion. And if this is true, what's about to happen will make the Chinese breakthrough seem like a mere footnote in the history books. This new technology, known as plasma-ion fusion, is not just another evolutionary step in batteries. It's a giant leap that could bury lithium's dominance once and for all. Unlike traditional batteries, which rely on the conventional movement of ions, this system uses plasma-activated aluminum microstructures stabilized in a quantum network. In practice, this means much faster energy transfer and unparalleled energy retention, something the current industry still can't even replicate. If placed in an electric car, this battery could maintain peak performance for over 20 years without a drop in range. Another impressive detail is that the cells in this battery are designed to self-repair. Small microscopic damage, which would normally shorten the lifespan of a lithium-ion battery with each charge cycle, would be automatically repaired within the structure. This transforms what is currently seen as an expensive consumable with a shelf life into a virtually eternal component. For the end user, this means lower maintenance costs, greater product reliability, and a significant leap in vehicle durability. And it's not just longevity. The aluminum-ion fusion system operates at temperatures up to 50% lower than conventional lithium-ion batteries. This eliminates the need for complex and heavy cooling systems, which currently represent a significant cost in electric vehicle manufacturing. With less weight and fewer cooling components, the car gains in efficiency, range, and even interior space. This has a direct impact on design and performance, not to mention reduced production costs. Speaking of costs, internal estimates suggest that each aluminum-ion fusion battery pack could be produced for around $1,200. For comparison, a lithium-ion battery pack used by competitors can cost between $5,000 and $10,000. This massive price difference not only gives Tesla an advantage in launching more affordable cars, but also creates a nearly insurmountable barrier for rivals that rely on the current production model. It's the kind of cost-cutting that completely changes the market equation. But perhaps the most strategic point lies in the material itself. Aluminum is abundant and widely distributed in over 150 countries, eliminating the geopolitical vulnerability that lithium poses. Tesla has reportedly already secured contracts to secure 12 million tons of the metal annually, ensuring it won't have to bow to suppliers who might use the raw material as an economic weapon. This also means freedom to set prices, plan production, and expand without fear of political blockades or trade embargoes. The geopolitical implications of this shift are enormous. A single move could drastically reduce the strategic value of China's massive lithium deposits, undermining what is currently seen as a trillion-dollar competitive advantage. If this technology reaches scale, the white oil of the electric age could become obsolete before even reaching its peak exploitation. China, which currently controls refining and dictates the rules of the game, could see its main power card in the sector lose relevance. Behind this progress, there are signs of infrastructure being built in secret. Inside the Texas Gigafactory, rumors point to a division called Eclipse Chamber, reportedly dedicated to perfecting the plasma reactors that make this battery possible. Meanwhile, there are reports that at least 2 prototypes equipped with the technology are already undergoing road testing, operating under extreme conditions to validate performance and safety on a large scale. Everything indicates that Musk is not only betting on this technology, but also accelerating its arrival to market before the industry realizes the shift. While the market's attention is still focused on lithium, Musk is reportedly quietly leading a global operation to ensure the transition to aluminum occurs without external dependencies. This initiative, dubbed Operation Starforge, includes the construction of a $4 billion gigafactory in Iceland. The choice of the country is not random. Its virtually inexhaustible geothermal energy will power 3D plasma reactors, capable of reducing the production time of new batteries by up to 60%. The goal is to reach 200 GWh per year by 2026, enough to power more than 3 million units of the future Model 2 without using a single gram of lithium. This movement is part of a strategy of extreme vertical integration, going far beyond manufacturing batteries in-house. The idea is to control every step of the process, from aluminum extraction to final distribution, with logistics systems managed by artificial intelligence. Agreements have already been reached with mining companies in Australia, Guinea, and India to secure up to 15 million tons of battery-grade aluminum per year. This means that when the technology is ready for scale, there will be no supply bottlenecks capable of slowing down production. In parallel, Tesla is investing heavily in refining infrastructure. One example is the $1.5 billion aluminum refinery in India, designed specifically to process microstructures for plasma ion fusion. This facility, scheduled to begin operations in 2025, will eliminate the need for intermediaries and further reduce production costs. Unlike the lithium supply chain, which relies on a few countries and suffers from geopolitical volatility, aluminum offers a globally diversified and more stable supply chain. Another advantage of this operation is the implementation of an intelligent logistics system based on neural networks, which optimizes the entire flow of materials and components. This automation can reduce transportation and delivery costs by up to 40%, in addition to increasing production speed. This allows Tesla to bring new models to market at a faster pace than any competitor, making it difficult for other automakers to keep up. The projected impact of this shift is aggressive. Analysts estimate that if the Model 2 launches at a price point close to $17,000, equipped with the aluminum battery, sales could reach 4 million units by 2027. This would represent a roughly 25% share of the global electric vehicle market, a share capable of redefining the balance of power in the industry. Companies like BYD, Toyota, and Volkswagen, accustomed to competing within the lithium-ion paradigm, would be forced to completely rethink their strategies. But Musk isn't limiting this technology to just automobiles. The versatility of aluminum-ion fusion batteries opens doors to applications far beyond electric mobility. They could power artificial intelligence servers, Starlink satellite communication systems, Neuralink brain implants, and even large-scale residential storage solutions. With lower heat generation, longer cycle times, and the absence of rare earth elements, these batteries could replace many of today's energy systems. This diversification of use is also a way to shield investment against potential failures in the automotive sector. Even if the mass adoption of electric cars faces obstacles, the demand for efficient, low-cost energy is virtually unlimited. This means that, regardless of performance in the automotive market, the technology would have a guaranteed place in other strategic segments. What's unfolding behind the scenes is a shift so radical it could rewrite the global energy map. If aluminum-ion fusion truly delivers on its promise, the Hunan lithium deposit, valued at $1.3 trillion, could see its strategic value plummet by up to 80%. This devaluation would not only be an economic blow to China, but a rupture in the logic that currently underpins the global race for lithium. The trump card that could give Chinese industry decades of advantage could end up becoming a highly valuable asset without practical applications, leaving investors and governments facing an unexpected scenario. For Tesla, the ideal timing for this shift is calculated with surgical precision. Analysts predict that the Model 2, equipped with the new battery, could debut in 2027, not only with an aggressive price tag of around $17,000, but with features that redefine what's expected of an electric car. We're talking robust range, ultra-fast charging, and decades-long durability, combined with the ability to tow heavy loads without loss of performance. A proposition that puts the brand years ahead of those still stuck in the physical and economic limitations of lithium. The impact of this launch could be devastating for companies that have built their long-term plans on the lithium supply chain. Automakers like BYD, Toyota, and Volkswagen, accustomed to competing by adjusting prices or improving technology based on the same foundation, would have to face a competitor with a structurally different product and much lower costs. This means the game will no longer be decided by production or marketing efficiency, but by the ability to access a technology that, until now, no one else has mastered. And Musk's ambition goes beyond the automotive industry. The versatility of aluminum-ion fusion opens up strategic applications in sectors such as artificial intelligence, space communications, and healthcare. Dojo AI servers, Starlink satellites, and Neuralink implants could operate with greater energy efficiency, less heat, and much longer operating cycles. This not only increases the reliability of these systems, but also significantly reduces maintenance and replacement costs. There's also a direct impact on people's daily lives. Imagine home backup systems that can power an entire house for several days, without noticeable wear and tear over the years. Or medical devices that run on compact, reliable batteries that require much more frequent recharges. This democratization of access to high-performance energy could reduce inequalities and open up opportunities for regions currently dependent on unstable or expensive grids. Another relevant factor is the elimination of dependencies on rare earth metals or supply chains concentrated in a few countries. Aluminum's widespread availability neutralizes the risk of trade blockades or price wars, making the transition to this technology much more stable and predictable. This characteristic could be a decisive differentiator for governments and companies seeking energy independence in an increasingly polarized world. Musk also seems to understand that mass adoption of this technology depends on scale and price. Therefore, the entire ecosystem surrounding aluminum ion fusion is being designed for rapid, high-volume production. From contracts with mining companies to logistics automation, each step is being carefully planned so that, when the launch happens, there are no bottlenecks that prevent Tesla from delivering millions of units in a short time. This potential revolution isn't just a business move, it's a planned disruption to break monopolies and redistribute energy power. By betting on aluminum as the basis for its new generation of batteries, Tesla is creating a model that can drastically reduce the cost of electric mobility and make advanced vehicles accessible to a much larger portion of the population. It's no longer about competing within the current system, but about creating a new system where scarcity and dependence on a single resource cease to exist. It's the kind of change that redefines not only the market, but also the way people relate to technology. This scenario opens the door for families who never considered owning an electric car to finally make that choice without compromising their budget. With prices up to 70% lower than current models and batteries capable of lasting decades, the vehicle replacement cycle would completely change. Instead of thinking about replacing a car every 5 or 6 years, consumers could plan on using it for 20 years or more, with near-zero maintenance costs and faster recharging times than filling up a tank of gas. Furthermore, the environmental impact of battery production would also undergo a significant transformation. Aluminum, being easier to recycle and widely available, reduces pressure on sensitive ecosystems and reduces the carbon footprint of the industrial process. This aligns the technology with global sustainability goals and makes it more feasible to comply with climate agreements without compromising the expansion of the electric fleet. In practice, the transition to this technology could accelerate the decarbonization of mobility on a global scale. From a political perspective, the change breaks the concentration of power over strategic resources. Today, a few countries control the majority of refined lithium, creating vulnerabilities for nations dependent on these imports. With aluminum, this dependence virtually disappears, redistributing production capacity to different regions of the world